So now we sort of know how to split it into components, because we could always say that what you usually have to do is say that something like Rx equals R times the cosine of theta. So if we know R and we know theta, we can find Rx. Now, let's say that we have a bunch of other information about the x direction, or we have another vector. We can add Rx, and if we've got some other vector down here, we'll call it P. If we also know over here, if we also, let's say we know Px right there, then we can very, very easily just add them. And this is a way to do it. Technically, we just found the I component if you're using IJK. So, but what we can do now is if we want to say, well, I want to know what big vector R plus big vector P is, graphically, I'm not very good at drawing. So for me, it's a lot easier to do it in components. So if I can find the x part and I can find Px, actually, just to mix it up, we're going to put this angle, we're going to call it alpha, and it's a vertical angle, so now x is the opposite side, so we have to use sine. So now we can just add these two together, and that's totally okay. And that's how you can add R and P. You can do the same in the Y direction, same in the Z if you've got it. So I will tell you, if you're in 3 dimensions, you really need to watch these because you have to consider what planes you're looking at.